So that means VB train is what? It becomes the successor of B. Okay. Now, if you remember the target function, the function VB cap x naught W naught plus W1 plus x1 multiplied by x1 plus W1 multiplied by x1 plus W2 multiplied by x2 and so on. So, in that function we have to actually assign values to W0 to W6, and then we have to adjust those weights also. Okay, because we can choose randomly and then do the adjustment. So we require certain methods or training algorithm. Once the weights are adjusted to their values, that means we have trained the system. So our training can start from by calculating error. So VB train minus VB cap. So you take the difference between the error and the actual value, put a square the error, do summation for all training examples, and that is your error. Now with this error, we can do adjustment. There are various algorithms like LMS, least mean square algorithm, and gradient descent, etc. There are many more, okay, with slight changes. The key idea is how to adjust the weight. So focus on that, how the weights are adjusted in particular algorithm. For example, in LMS weight update rule, each training example, for example B, VB train B, use the current weights to calculate the V cap B. And for each weight Wi, what you have to do is, the equation, you will adjust the weight. This is the current weight plus the n eta stands for learning rate, difference of VB train B minus V cap B multiplied by xi. So but for particular xi, you can calculate your weight. This is how you will adjust the weight. The only issue is the fixing the value of learning rate. If learning rate is too high, then your algorithm can prematurely converge to some weights which may not be accurate. And if learning rate is too slow, it requires a lot of time to adjust the weight. Okay, so the ideal value for this can be 0.5 or 0.05, and you can iterate it algorithm. You iterate your algorithm and get the weights adjusted. Now, see, if you are applying ML on some tasks which are not games, in game playing there should be 4 components. For normal AI problems, machine learning problems, you can have the algorithm, you can train the weights, and that's all. Okay, but over here you can have 4 components. First is the performance system. Second is the critics. Critic means which analyzes the certain parts and comments. Generalizer, and then we have experiment generator. Now we will take each one by one and see what it means. So performance system solves the task. Okay, playing checkers using the learn target function. Take a new game as an input and produce a game history as output. Use an evolution function that improves the performance over the time. Critic is analyze the game history and generate the training examples. So critic will actually analyze and generate the training example. Associate each game state with the estimated target function value. It will estimate the value. Implements a training rule to refine the evolution function. Generalizer, what it does? Converts the training example into generalized hypothesis. Uses the LMS algorithm to learn the target function. Produces an updated evolution function based on learned weights. an experiment generator. Experiment generator will actually keep on generating new problems, okay, for training. Maximizes the learning by selecting strategic positions. Uses a simple or advanced strategy to improve the learning efficiency. So we should have 4 components because we are putting AI into the game. Okay. Design choices, and we have certain design choices, and out of which we can choose some of the design or one of the design choice, and we have to ignore the others. So that means we have to operate in certain constraints. Use a linear evolution function with 6 board feature, which we have chosen. Limited by the expressiveness of the function representation. Yes, it is a linear function, simple function. Okay, it will map into a straight line in 6 dimensions. Okay, which may not be good. Okay, so that means they're capable of learning an approximation of optimal function. Learning potential can effectively improve the gameplay but unlikely to surpass the human champions. More sophisticated representations like neural network enhance the performance. Similar methods applied to backgammon have led to competitive AI players. So it's not altogether bad, but similar idea to how to make a program to play board games, okay, is presented over here. Now you see, the final design of the entire program, we have an experiment generator. It formulates the new problem. We have a performance system that actually traces the solution game history given to the critic. The critic generates the training example and generalizer actually does the hypothesis. So these 4 components will actually improve your game's AI, and it can improve to a level that it is competitive enough to play against human champions, okay, if followed in this way. So this is a summary, total overall choices of constraints and everything. Now let's see how we actually planned this entire program, how we formulated this problem. So we have determined type of training experience. We have 4 choices. We can call game experts. We can ask the game to play against itself, the program to play games against itself. We can make table of correct move and some others. So in this particular example, in this session, we have chosen to play game against itself. That is why generalizer and critics and all those things are required. So after determining the target function, what we choose? We have chosen the board values. We can also choose the board moves, but over here in this example, we have chosen the board values. Then we have to determine the representation of the learned functions, and as we know from the previous slide, we have chosen a linear function of 6 features, okay, with some weights. So linear function of 6 features has been used. Then determine the learning algorithm. The learning algorithm, that is for training the weights, we have chosen the gradient descent, because LMS is a type of a gradient descent, and we have completed the design. Now this system is if left over to play against itself, will keep on improving itself, and finally it will be competitive enough again to play against any champion or against any human player. So thank you for all. This I hope clears what is well-defined problems, okay, and it gives an idea that how you apply the ML algorithms on games or any other problem, okay, in which the machine learning, there is a problem on which you want to apply a machine learning. So the most complicated is playing games. So I presented an idea of well-defined problem to play against the game. You can use it in games, gameplay. Okay. So thank you for patiently listening. We will meet again in the next video.